Hands, okay. Who of you through the Green Software Meetups group? And who from ASML? So the bad news, I really have to first tell some bad news. I only have 30 minutes to talk about this topic. I would love to talk hours about this topic, but sadly, that is not going to fit. So I'm Wilco Burggraaf, working for High Tech Innovators, Green Software Champion since last year. And this was me in Paris. Some of you are here as well who were in Paris, so that's kind of cool to see. Yeah, I'm also working as a solution architect for a nature data bank in the Netherlands. But this was December, and this was me in that same month. It was Christmas, I had 2 weeks off, which is for me the worst time ever, because I cannot do stuff, and I really like to solve puzzles. So I already was like, since that summer, I was focusing on how can we make software more visible. So what you're seeing here is all these fluctuations and data points in milliseconds. So until that point, last August, when I was looking at how can we better measure the utilization of the cores of software, most of them were just 3 data points. 1 in the start, 1 in the middle, 1 in the end. That was it. So figuring that out, that was kind of the first thing that I really put a lot of effort in, and also starting realizing that there was a lot to do, and I'm going to explain what you can do here later on in the presentation. But the other thing was, for me, was like I had this eureka moment where I was like, we've been focusing on green IT, sustainable IT, especially in green software, on software engineering. So how do we write code and architecture and that kind of stuff, but not often looked really how, as mainly the core components that consume the energy, the CPUs and GPUs, how do they actually work, and how does software influence the hardware? So I came to 3 main conclusions. 1, there is a big impact on how you queue up your code, which is kind of all the people are standing in a line, and this is kind of small code parts. The second thing was, how do we wait? So I've seen code, and there are other examples, where you're waiting on something in a while loop, using a CPU core for 100%, and the only thing you're doing is waiting. It's pretty cool, but it's consuming a lot of energy. But also bottlenecks. So there were kind of 2 key things that I like, okay, that is something. And the third thing is, sometimes I say green coding is almost equal to parallel and async coding, because you want to use your resources as optimal as possible. This is kind of what I always say is the unwritten rule in sustainability, that the devices or the things we hire, that we use them to the best utilization with the least amount of negative impact. So there were kind of the 3 core things. So then if you focus on the CPU, so there's more in a server rack or in your computer at home or on your mobile phone, there's more going on, but the CPU, it consumes a lot of energy. So if you just have, in this case, 6 cores, so the 6 blocks are the CPU cores in this case, and they're now 2 boosted. So okay, that can happen. If you look at CPU specifications, you know that certain boost clocks can happen. But this will probably not happen, because if you boost all the cores often, you will overheat the CPU, unless you maybe have a certain hardware that can handle this. But what often happens is not exactly this, because everything is fluctuation and dynamically adjusted, right? So, but the gigahertz goes up and down all the time because of essentially the compute and everything that's going on the CPU. So that happens in a certain voltage. So of course not all 1 voltage, but different types of voltage, changing all the time. The CPU package, we're going to forget for now, even the Green Software Foundation. If I ask about them, like, should we count this in to calculate the actual energy use? And like, yeah, we actually don't know what we do with it right now, so we're mainly focusing on the cores. And then eventually you have certain watts. So this came to the conclusion, okay, so you can have the exact same code, but depending also on the hardware that is actually running it, can have different actually energy consumption, not even depending on the operating system or other stuff. So it's like, okay, then I was thinking, so what does sustainable IT mean beyond hardware efficiency? So even if hardware is efficient, software inefficiency still burns energy. And this happens a lot. If you talk to people who are in IT for a long time, they can tell you all these stories about servers running that nobody knows what they're doing, or we have servers always running on 90% and we keep adding resources to it. Do we know what it actually does? No, but it runs in production and we cannot let it fail. So there's a lot of compute waste going out there. This image I think most of you have seen a lot of times, but I always try to come back to it, because to some degree the universities and a lot of organizations all kind of agree that to some degree if you're connected to a certain grid, that you, from electricity perspective, you indirectly emit emissions, mainly to stabilize the grid and that kind of stuff. And then from that perspective, also, one of the manifestos of the Green Software Foundation, and they're really serious about this aspect, is they always try to choose the option that advocates for abandonment. I never heard about that word before that, but for abandonment, reducing emissions, not neutralization, offset emissions. So really try to lower the amount of energy use and emissions down. And yeah, I really like, so there's not only just the Green Software Foundation, there are really members who have been really serious looking into this and taking this seriously. So the other number, I don't know if you said kind of the same number, but this was last year from the IPCC, and I always like to set it in grams, because then it's easier to become and compare things. Sorry? More zeros. Yeah, also. Also. It's a lot, probably a lot higher. But then if you look at the other stuff, and I hope that I copy-paste the right numbers from the report of last year, this is publicly available. So the scope 3 is, so in this case the 41 is in the gigatons, the 12 is in the megatons, the scope 1 and 2 together are 32 in the kilotons. And if you just look at computers, if you run it in a hyperscaler and you take into account the indirect emissions you do, already with 1,000 virtual machines, you get already in the metric tons. And if you have around 15,000 virtual machines, you get into the kilotons. So what we do actually matters. And that is why I really like the thing that I'm focusing on in the last 1.5 years. Oh, I'm going too quickly. You haven't seen that. So the answer, what sustainable IT really, really solves, is kill daily waste. Efficient, so concurrency, everything, so make it sure that what all is going on at the same time, that you do it in a really efficient way, that you do it parallel. Not that you should do everything parallel, but if that core is always at 10%, should it be that way? And also that you're very aware of all the disk I/O going on, network I/O going on, and that kind of stuff. And especially on scale, that really matters. So the second one is extend system life. So in this case, from the software. So although this is not new, this is probably what a lot of people say, yeah, but we've been talking about this already for decennia, that if we build a system around the process, that it's going on for the next 10 years, that we do it in a way that is adaptable and that we don't have to rewrite it every year, or with vibe coding maybe every 3 months. That's a different story. And then, yeah, through CO2, back to code choices. So underutilization and bad design. They hide to some degree emissions. So this is from the Green Software Foundation website. And this also started me thinking about the course at Christmas. The first time that I saw it was January last year. And you want eventually to be kind of in the range of 70 to 9% or idle, one of them. Not fluctuating the whole time, that has a whole story. So that's kind of the ideal situation for the most efficient way to consume the most efficient energy. So let's shift from watt to value per watt. So every user action should be connected to the minimal operations and energy that you use for that to do a certain transaction or calculation or do an order on a certain web shop. So what is the DevOps plus framework? So I don't know who of you are following me on LinkedIn, and I spam a lot, so I already say sorry. So I've been telling about the last 3 months that the team and I at High-Tech Innovators, that we've really been trying to focus on a framework where we, for DevOps teams, can create a certain set of rules that you can use in your daily job. So instead of that, it's important that you actually know what are kind of the things that we can do. And the first thing that is important to understand what DevOps is, and that's mainly to do with breaking down silos. So of course, this is what everybody knows. So as DevOps started working together, you do everything together from plan to eventually code, build, test, deploy, run, monitor, and improve. Some would say like, yeah, but there should be a security guy in here or a girl, or testing and all the other roles. So this is also the reason that we eventually chose for DevOps++, because you can keep adding things to this. And sustainability as well. The other thing, of course, is automate flow. So try to do as much automated as possible, less manual work. And the last one is feedback loop. And I think this is, by the way, the most important thing of the whole process, that eventually you do stuff, and to know if you do the right thing, that you get feedback on as quickly and as possible. So yeah, what is then DevOps++? So add sustainability lens. And for me, the most important thing was the understanding that it was not per se about what everybody's looking to, CO2 and energy, but understanding the actions that will lead to less energy and CO2. And that is the hard part, because then you need to experiment, you have to experience, and there's something, and our line of field is really like immature, we're trying essentially to grow it together. But yeah, and then the other thing is software, and I have a complete different talk on this. Software has impact on your hardware. Everybody had a mobile app on their phone that overheated their mobile. And although you don't see it, it has an impact on the battery and the device at a certain point. So yeah, the other thing is, make sure that governance is built in. So solid doesn't have to be solid. I understand these days that some people say we should do solid anymore, but code smells. And also really take energy efficiency checks in there, because energy and compute efficiency, they're not always correlated. And embed it into the CI/CD, so that you do it in a way that if not only a team who thinks that sustainability and green is important should work with it, but also teams who are kind of like, how do you say, confronted with it, hey, this is now in our pipeline, and we now also have to deal that it not only has to be quick, but also using less energy. And I think that scales better. And then system optimization, so the energy performance to business value and the user impact. So not only that it just does stuff, but it, like I said before, that the business value deliver in the most efficient way. So eventually, so I started with the core concepts of underutilization, of waiting patterns, bottlenecks, and the parallelism. But we started to kind of identify 10 core principles. One of, I think, is mentioned a lot in a lot of other talks. Always try to how do you say it, combat idle compute. And idle compute is not always like a server doing nothing. It can also be, it does something, but it doesn't really add anything to the operation. And maybe we should shut it down, so downscaling, that kind of stuff. CPU load, what I just also said multiple times, that if it runs, the CPU is at the utilization of 80%, but is it actually doing anything useful? Right-sizing memory, I think this is the core thing that a lot of people are currently busy with. So I always give this example, like, let's say you have a Java application that often uses a lot of memory. By code, can we, how do you say, do a change where it uses less memory, so it runs on a smaller container, has a smaller footprint, and eventually this also gives insights for the architects. I/O visibility, so stop blaming CPUs, fix DB locks or other things. and most of the time the solution is add extra resources, and then the question is it even then solving anything? And then validate early, so performance testing and energy performance testing in already in pull requests, so really shift left. Prune data. So yeah, you can build everything serverless and microservices, but aren't we like moving around data all the time to eventually compute it everywhere and then use extra energy? And then the other one is compute location. So in the Netherlands, we have a lot of solar panels at people's home. But if we maybe do more like with WebAssembly, which is kind of the next one, at people's homes, at their devices, that we maybe can also use that green energy, we could also improve on that one. So being really aware, where do you compute? What is the exact location? Performance not by perception. So one of the workshops, what I start with is, most people think if the API is running below 2 seconds, I'm done. It's fast enough, it's okay. But most of the time, if you would take the time, you can really like go to like 200 milliseconds. And then you often say, yeah, but what does it matter? Well, if you have APIs that are used by millions of users or 100,000 of users, then it actually does matter. So it's also often about scale. I would always say, like, focus first on the application with the most, users or the most resource use, and not try to make every application sustainable green, which from a principle perspective is really cool, but it doesn't always make sense. And then, yeah, make sure that the user actions, transactions are really like in a metric in everything you kind of do. So then it's kind of all about the playbook. So how does this kind of work? So you need to make sure that if you start scanning your code base, that you find the top 10, 20 things you can improve. And so we thought, okay, but how do we expose this? So we found out for ourselves that the ideal environment for this is integration testing. So if certain systems or components come together, can you think of an integration test that not only make sure that nothing breaks or fails or has a certain load, but can we find the underutilization, the bottlenecks, the waiting patterns, can we find them through certain integration tests? And eventually there could be, and in the beginning it will be a lot of manual, but can we eventually also fix then that with automatic code changes and eventually infrastructure as code changes? And then what I find then is important, because my focus, and also I think a lot of people in this room is focused on the green and sustainable part, is then validate in acceptance and production that you're actually now using less energy and emitting less CO2. So, yeah, how can coding practices reduce energy consumption? That's a good question. Beginning of this year in the workshop we started, we used all these kind of tools. To every software build, we let the tools run to see what happened. And this is the same picture as in the beginning, but with more details. So this is an API. And in the beginning, some data is loaded. And on that data, what we often do is we do some sorting, we do some filtering, we do some group buying, we do some computations on the code, and then we give it back to the front end. And by being more, conscious about how you utilize the CPUs and the cores and everything here, you have different patterns you could use. So often another picture that I show is that in the workshop there was eventually they got it on almost perfectly 80% the whole time and a half second quicker. So one, it's quicker, so you're using the resource less. And the other thing is because if you have less fluctuations, I talked earlier about a mobile phone that could overheat. If you fluctuate less, it has the temperature stays stable and you have less hardware wear even on servers. Still, that needs to be researched. I talked with this about with technical universities, and the research still needs to happen. So we need to get proof on that kind of things. So, but again, how can coding practices reduce energy consumption? So, as an example, you are all in this room currently now working for express.js, and this is an open source GitHub project. And you're part of the development team. And so express.js had in total, they did an expectation of how many, so 5 to 10 billion times. So that's used a lot. And yeah, it's just GitHub. So then the question is, so this is just public available, so then the question is, there's nothing to improve, right? Right? That is the question. So let's see if, I'm gonna use ChatGPT, and of course everything is random, so let's see if this is gonna work. So I set up just a system prompt with all our rules. So we have a kind of a set of all the DevOps rules, all the principles that were just shown. And I also uploaded the source code of the express.js in there. And I set up previously 5 prompts to see if he can find anything. By the way, it has a footprint, GenAI. We can talk about this in the break. And also, it's slow. That is my biggest issue with GenAI. If you would this kind of things on a full code base, it would take way too much time. So you need traditional machine learning analytics to kind of do this. But let's see what he came up with. So one of the things that I know, normally it gets with the middleware. Oh, he does a lot of explaining right now. So he's already. So what you here see is a theoretical model, here in the description. So what we say for this theoretical model, and this is in practice will never be the case, is that every micro operation is equal to 1 hertz. So that kind of sets a frame. He has kind of some capacity to do estimations. So why is that then useful? Because it can lead to sustainable decision making in the code. And that's why it makes sense. And in this case, he also starts then to set up like, yeah, if we do everything in sequence, it's probably not the most efficient way. So what is his solution? Like I said, it's Gen AI, so it's always the question, what is he coming up with? So he says now, well, pruning the middleware, cutting that traversal, low latency, fewer watts, greener stack. Yes, okay, cool. I not completely understand what he means with this right now, but it sounds good.
Could you please complete your thought?
I'm
ready to help with whatever you need.
Okay, thank you. That's also AI, but that was not the one that was included in this demo. So let's see if we go to the next one. If we get something more useful. So, header lookup. So there is a code file, request.ds, and it does probably some where normally strings are going on. Yep, there we go. And he now every time use stringify or something. He does something with string lower to lowercase, and he says, well, I don't really like that ID, so he's probably doing some refactoring. Let's see what he comes up with in the end. So he says, well, before the refactoring, we had like 8,000 micro operations, and after only one normalization, it's a lot less. So net gain 10% fewer cycles per request. Of course, this whole idea is super, how do you say it, simplified. In practice, if we would really do this, it has many more factors, and we also would not only look at the static code, because this is just static code, and we would take observability data and connect it to it to really see what takes long, what is shorter. The third one. So, like I said, sometimes I had way better examples before. That's what, of course. Yeah, I have one below this one. That was as backup, but let's see where it comes up. So now serialization, duplication. So who of you knows what serialization is here, right here? That are all the developers in the room. Nice, that's a lot of you. So what does he say? He says, well, this suppose it's the same thing. Yeah, here's stringify again. Yeah. So can you rephrase that?
So you're using like a quickest version of ChatGPT?
Yeah, that's for a reason, because else we're waiting here for drinking coffee and that kind of stuff. Yeah.
Before you did like a more powerful version and then
No, that's completely true. But for me, the core thing is kind of the thing here on the bottom. So if you do it like not in this Rust version, but like in a really analytical way with all the things we now do with DevOps Plus, yes, it is in theory possible to find the ways to improve the systems in a way that you use less energy and CO2. That was kind of the core thing that I wanted to show. If you want to talk more about this, in the break I can. We've done a lot of like experiments with this internally. So then the last part. So how does testing contribute to the greener software? So what I already said, we really focus on the integration part, where we really try to detect the underutilization, bottlenecks, and waiting patterns. And then we use the production, acceptance and production to check if we actually use less energy and CO2. And then, because Gen AI is slow, you also need some traditional AI machine learning to find the top 20 first before you start using Gen AI. And it's I most of the time say it's like test experiments, like with user interface testing, that are kind of the least amount of tests you have. kind of the same with Gen AI, like do first a lot of things you can get eventually to the top 20, 30 files, and then start using Gen AI to do more of the interesting stuff. So I wrote an article on Medium about this. I'm gonna write a lot more. The last few weeks I've been traveling, so from the next week I hope that we gonna eventually add way more to a GitHub that we're creating. Right now there's only the basic rules in there. The idea is that in the coming months, I wanted already to have way more in there than there's in now, to eventually add there the best case, the worst case scenarios, and the things we eventually, the knowledge that we gather. So yeah, that's kind of the core of this presentation. Anyone, any questions? Because this is the part I like the most. Yes?
So in companies with, let's say, quite a lot of technical debt,
Yeah.
would you say there is a trade-off between stability and efficiency?
The answer is yes. But with technical debt, if you do not have access to the source code, the best way, so there are multiple companies in the Netherlands who transfer their mainframes to virtual environments. And the cool thing from the moment you do that, from the hardware to actually virtualization, you have more control in what you can do in the infrastructure. And you can also do there more stuff to have influence on that, exactly that, so less energy use and CO2. The other thing is, and this was what Legal in General last week when I was doing a presentation there, they were like, hey, we have engineers who still work on the mainframes, but the problem is they have a lack of idea what the code actually does. And we discussed, can you use Gen AI to get a better understanding of that code? And it is actually very possible. So yeah, tech debt is a difficult issue to tackle, but there are many ways, more than these two, that you could approach it. Yeah. Other questions? Oh.
Yeah, so you mentioned that it's nice to have the direct feedback from your build cycle.
Yeah.
So do you then also use these rules that you have, like if you create a new PR, that you do like automated check on your
Yes.
PR or your code?
Yes, that is the idea. The only issue is, like I said, if you want to do everything with Gen AI, it is very costful.
If you just do it on the PR, it's not that much.
No, it's potentially not too much. You could do that. You could do that. And you could even do that with open source. So the things that I just showed, the only thing is that the AI needs to have access to the text in the code files, of course. But even like, although the fast model is not going to give the same quality of responses as the reasoning model, who does also have more parameters, of course. But yeah, and it's something I think we should more experiment on. Also because we now came to the conclusion, I think, with hopefully a lot of people in the community, that we're not using 2 kilowatt hours for one prompt. It's not that that AI is like, there's no negative impact. There is. But it's very important to understand what like the comparison is to other things you do. Oh, sorry, there was other first in the back.
Those things, I wonder, I'm not a technician in happening here, so I try to understand what's going on, and maybe for a little part I know what you said.
Yeah.
I wonder if you do your best, how effective is it?
Okay, so
Something is
yeah. So we really like, myself, to work together with other companies who are now investigating this kind of stuff for the last 4 to 5 years. And Metafinance, I have to say, in Germany, they did some multiple researches, and they came to the conclusion that just pure with software, that in some cases, so the extremes are 80%, but between 40 and 60% should be possible. We aim at least 5, because I think we still need to learn a lot on what actually works, because we also had a conversation with a company who tried to do it on their whole portfolio. Let's see if we can like optimize everything. And then they created all new issues and sometimes inefficiencies. So that's why I always say, like, try to focus on the application or resource with the most amount of negative impact and start there first. Yeah.
If I understand you right, say this is about a cloud something, data center.
Yeah.
If you do your best there, then you're saving 60% of the electricity of the data center?
the time you hire the resource there. So yeah, and then the question becomes, so this is of course a lovely debate, because as a user, especially with cloud, we want to use it as less time amount as possible. A data center, they want to utilize it to the maximum with the least amount of negative impact as they can. So they have a different, how do you say it, focus driver, which is okay. But I always say, like, every renewable energy that you don't use, someone else can use. So that's already, I think, a nice principle to start. But yeah.
Yeah, my head is spinning about this, and I'd love to talk more about the whole topic with you later on, maybe not here.
Yeah.
We have a fair trade software company in Ghana.
Yeah.
And 25 software and data engineers, and we do part of our work also for African context. And funny thing is, here we have a sort of a luxury problem because we have electricity and internet almost always.
Almost, yeah.
There it's not like that.
Yeah, true.
We have a lot of places where there's half of the time the light is off, there's no internet and so on. So you always have to, and you also have people,
Yeah.
end users who have old Android phones only.
Yeah.
Even the Nokias, if you still remember.
Yeah.
You were still a baby, but you
Yeah.
were around.
Yeah. I was not a baby at the time. I really remember.
So we are being hired by people who want us to build for that
Yeah.
context and these target groups. So we're constantly economizing both on the internet traffic and also on the electricity you need to use and so on.
Yeah.
I'm sure we can benefit from some of your insights.
Yeah.
But I also think it's like the bigger picture is also important. Like ASML is also looking at the bigger picture of everything they do.
Yeah.
Due to like the devices, for instance.
Yeah.
I think it's very important to think of the relation between the software you build and then the devices you use.
Yeah.
We bring all devices to Africa. People
Yeah.
in the jungle use them for 5 or 10 more years. Offline, for instance.
Yeah.
It works fine.
Yeah.
New battery and you can good to go.
Yeah.
But then, of course, like Windows, you need a new version, Windows 11, to run this or that.
Yeah.
And then new machines with new materials, expensive
Yeah.
and terrible mining in the Congo and so on. So
Yeah.
I think the relationship with the software, with the hardware,
Yeah.
is also very important.
Yeah.
And I'm just curious if you thought of this trade-off also.
Oh, there's so many thoughts here. So to first start. Yeah, first start. Technical University of Delft, they did like a full Kubernetes cluster on old phones. That is awesome. I think the brightest minds in sustainable and green IT and software, they kind of all think that we're gonna eventually go from central more to decentral again, more distributed, and sometimes also offline. So that knowledge makes a lot of sense. The only issue is because we have multiple startups in the Netherlands focusing on being very close to renewable energy. So they rely on a distributed network because they just have a small box near a farmer or someone's home. Is that scale? Because a lot of companies who would like to implement such a thing want it to be secure, want it to be stable, reliable, and scaling those things is the issue. On the other hand, if you deliver such solutions for, how do you say it, regions that really could, benefit from this social impact, I think that it's great, and I think we should focus more on that. And it also, I think, it has the ability to create new innovations that we eventually can use. So yeah, real cool topic. Yeah, I'm already way behind my time, so maybe one final one. You.
I was trying to understand what you did in your setup there.
Yeah.
It's actually static code analysis.
Yeah.
That run during CI/CD and it's just in the place of just two classic ones that we use.
Yeah.
Structures you use LLM.
Not always, but you can.
Because kind of interesting because LLM means, for example, analyze code in a static manner, but it really makes a big difference if you run the same code on Intel processor or
Yes.
Graphicon. It will be completely different
Yes.
energy footprint. So how
If my colleague was now in the room, because he was the first one kind of keep bringing this up, and I was like, yeah, you're right. You cannot do a static code analyze for energy consumption, for a demo, cool, without observability data. So you need to see how the code actually behaves when you run it, and then log that and use that information in the whole cycle. So we have kind of this golden rule that eventually, for all the solutions we create, it has to be both static code and observability information.
Do you have some suggestions how to implement this kind of profiling?
Not so easy to summarize. Sorry, no, but yeah. Maybe we can talk about that later. Yeah, and for everyone, if you want to know more, you can just send me a message on LinkedIn. I try to react to anyone, and often it also happens that someone comes with a great idea, and then I write an article about it. So, yeah. Thank you all.